short video just to demonstrate my latest ROS2 program that I've built. In short, what it is a robot that's launched into a gazebo simulation. It's a custom world with a maze which has QR codes dotted around it, and the QR codes direct the robot where to go. The robot has a camera attached to it, as you can see here from the RViz simulation, and then it also has Lidar, which I'll just show you through the gazebo simulation here. At the moment I've just got it opened up in a launch file that just opens it up into the gazebo simulation, so the autonomous node is not running at the moment. The reason for that is, if I just run this standard ROS keyboard node, you can see that it can be teleopt, and that's really useful for testing. But you can just see it's just a simple diff drive robot. This also gives you a bit of an indication as to the Lidar as well. So what we'll do in a moment is open this up with the full program so we can see it making its way around the maze, and you'll see it with all its warts and all, because it's certainly not perfect. And I'll talk through, whilst it's going through the maze, I'll talk through what needs to be done to make it significantly better. So I'll just close this. Before we open up the proper program, if you want to download this to your local machine to play around with it, have a look at it, edit it, use it as a base, whatever, my GitHub is benmay100 and the repository is QR code mazebot, and I'll put that in the description of the video as well. The other thing I'll just show you briefly is if you do clone it to your machine, what you're going to find is 3 packages as the description package. This has got the assets folder, so that's all the CAD files. A launch folder, that's where I can launch it in for teleop testing. The maze model, and I've done a whole other, so that maze which has the QR codes on it, to be able to do a custom model and import it into Gazebo with textures, you need to follow a certain workflow, and I've got a whole other video that explains that if you're interested. There's then the RViz config, URDF, all the Zacro files, the gazebo tags, the various modules, things like that. The custom worlds, and then a ROS gazebo bridge YAML file. There's then a bring up package that's just got the launch folder and 2 launch files. There's 2 launch files here because there's basically 2 driver nodes. There's a V1 and a V2. V1 was my first attempt. It's a little bit more simplistic. One of the examples of that is, for example, when the robot goes to turn a 90-degree corner, it just does it with a timed turn. V2 is a little bit more complex, a bit more robust, and it's leaning on the Lidar readings a lot more. An example being when it does its 90-degree left turns, when it wants to start off down another corridor, it's using the Lidar readings to effectively work out when the robot is pointing right down to the end of the corridor. It's not perfect, and there is a much better solution which I haven't done yet, which I'll talk through when we run the program. So let's get it running. So QR code mazebot bring up, and we would do V2. It's going to all launch fairly quickly, this, and start running, so I'll try and get this over here so we can see it starting. Okay, whilst that's making its way down there, we'll get these windows a bit bigger so we can see as much as possible, and I'll bring RViz across as well. So what we can see is it's successfully navigated its first corner. It's making its way down the next part of the corridor, and you can see here in RViz that it's picking up the QR code. That's telling it in this case to turn left, and then it's beginning its maneuver now. Now, one of the challenges I had when making this is for longer corridors like this one, and particularly this one here, getting the Lidar readings to pick up quick enough whilst the robot was turning, quick enough to register and send it off down its next corridor, was a bit of a challenge. So what you'll see is, particularly when it comes to this turn, you'll see it's turning very slowly to try and get around that. And what we're seeing going on here is, you might have noticed when it came up to the QR board, then it wasn't in line. And the program that I've built here is designed that it can recognize when it's not in line and try and sort itself out. So it has some sort of correction functions where it does a bit of a reverse maneuver, and that's what it was doing. We'll likely see that a few more times throughout this maze. So moving up to the long corridor now. That's it doing a reverse maneuver there, and it's going to just make its way forward slowly until it gets a good reading, which it looks like it's got. So this is the corridor that was in particularly causing problems. So let's see if it works for us this time. And you can see I really slowed down the actual turning maneuver for this to try and give the program time to pick up the Lidar readings correctly. Okay, so far so good. Now something I want to point out here is what you'll notice here is particularly on the longer corridors, you see that the robot's sort of snaking its way down. The reason for that is there is a PID controller built into this, but it's a simple one. And what it's basically doing is just trying to get a read left and right to check if the walls are equidistant. If they're not, so let's say it's closer to the left wall than the right wall, then it starts turning the robot right to try and sort that out. The problem is when it starts turning the robot right, the robot is no longer driving parallel down the walls, down the corridor. What that means is you get a false reading where it thinks it's central again, but actually it's slightly off to the right, and then it effectively overcorrects, realizes it's overcorrected, does the same thing in the other direction, overcorrects, and that's why we get that snaking behavior. And there is a solution to that. The solution, which is what I'll be doing next, is to actually, what you can do is you can take the Lidar readings and you can put them into a Cartesian plane, so into an XY plane, and using a little bit of trigonometry plus an algorithm such as a ransack algorithm, what you can do is then create a line of best fit that represents each wall. And then because you know that a certain one of your Lidar scans represents the robot pointing straight forward, you can then understand exactly how your robot is angled relative to the walls at any given time. And you then build that into the PID controller. So the robot is not only constantly assessing how far it is away from each wall, it's also constantly assessing what its angle is relative to the walls. So that's what I'll be doing next, and that will be a much more robust setup because of two reasons. One, it won't snake its way down the corridors like you see it doing here, and two, what it should allow me to do is have the robot driving down the corridors pretty much bang down the center, so it should land on the QR code in the right place each time and have to do less of these correcting procedures. But it's doing pretty well so far, and the correction procedures are a bit slow, but they're working. So penultimate turn here, so again a little correction procedure being done here. It's got itself nicely lined up. You can see again on RViz that it's reading the code, and then it's off to do its last journey down the final corridor, and this QR code here has the message of stop. So you'll see when it gets to that it will stop and the program will be complete. So we'll see it snaking its way down again. You can really see that overcorrection happening there. And we're lucky it'll land on the QR code nicely, but what I think is more likely is it'll have to do a corrective procedure, which I think that's exactly what it's going to do now. And there we go. So we've got maze complete. So yeah, not the best program you'll ever see, but a lot learned building this one, and really opened my eyes to how challenging it is to not just get the robot to drive through the maze without bumping into anything, but actually to get it to drive through gracefully without snaking around. And as I say, the next step for me will be to build V3 of this, if you like, which will use these lines of best fit and have a PID controller that's not just looking at distance from the walls, but looking at the angle the robot is relative to the walls. As I say, if you want to clone the repository onto your machine, have a look at what I've done, suggest any improvements or make any edits yourself, then please feel free.